This assessment asks us to synthesize the alkene molecule on the left, starting from acetylene and the benzyl bromide on the right. I've numbered the carbons 1, 2, 3, and 4 to show us that carbons 2 and 3 are going to come from the acetylene. Carbons 1 and 4 are both going to come from a molecule or two molecules of benzyl bromide, and so we've labeled it as 1 and 4. This reaction will start by deprotonating the acetylide anion, or deprotonating acetylene, to make the acetylide anion. This acetylide anion can react with benzyl bromide to make the first carbon-carbon bond. Just to make sure we don't make a mistake here, we can number the carbons, carbon 3, carbon 2. We'll call this one carbon 4, so that we know that we're going to have benzene attached to carbon 4 and then attached to the triple bond of carbon 3. We note that carbon 2 still has an acidic proton, so we can repeat this process to make the carbon 2 carbon 1 bond. And so we'll do the same thing, reacting this with sodium amide to deprotonate carbon 2, and then react that once again with the benzyl bromide, in this case calling that one carbon 1 because we're going to make a bond between carbon 2 and carbon 1. And so then all that remains is to draw the product of that step, making sure we don't drop or add carbons. That's why we number them. So 4, 3, 2, and 1. This gives us the carbon framework of the molecule we were trying to synthesize. But we have an alkyne, we need it to be an alkene. Specifically, we need it to be a transalkene. So we're going to do our reduction where we use sodium and liquid ammonia to make our transalkene. Once again, we check to make sure we have our carbons numbered correctly, 4, 3, 2, 1. We haven't dropped any carbons. This is the synthesis of the alkene shown.